So here's the deal. When you're picking a PoE switch, there are two things you absolutely have to check. First, how the power is delivered. Second, how much power each port can provide. And trust me, the first one matters more than most people think. Because if a power delivery method is wrong, it doesn't matter how many watts the port can push. Your device can end up underpowered or even worse, fried. So before we talk about a wattage, 15, 30, 60 watts, all that, let's start with how PoE power actually gets delivered and what's safe versus what's risky. Alright, let's start with Active PoE, the smart one. Think of like a smart charger. The switch talks to your device first, asks how much power it needs, and then sends just that. It adjusts the voltage and the voltage automatically. So your device gets exactly the right amount. No more, no less. Safe, efficient, and compliant with the standards like O2.3 AF, AT, and BT. Perfect for modern devices. You don't have to worry about frying anything. And basically, it prevents mistakes before they happen. Let's talk about Passive PoE. It's fixed power, used with caution. No talking, no negotiation. The switch just sends a fixed voltage and a voltage down the cable. If your device expects less, it can overheat or even get damaged. A common case is a passive 24 volts PoE switch connected to a standard O2.3 AF IP camera. The camera expects around 48 volts with negotiation. Instead, it receives constant 24 volts without any handshake. The results? The camera doesn't power down properly. Or worse, the internal DC to DC converter overheats and fails after a few hours or days. Another scenario. Installers reuse a passive PoE injector originally designed for wireless bridges and accidentally plugged into the VoIP phones or access point. There's no detection, no power classification. Power is injected immediately. In many cases, the device boosts once, then dies permanently due to the overstressed power regulation components. Passive PoE is great for specialized installations, but risky for most standard devices, usually used in custom setups. Only safe if you know your device specs exactly. Voltage and a voltage must match. If you're not 100% sure, always go Active PoE. It's safer, smarter, and works with almost everything. And also, always check your device power needs and think about a future expansion. Don't just buy by port count. Power, safety, and compatibility matter more. Now, once you're talking about Active PoE, this is where PoE standards comes in. Everything we're about to cover, PoE, PoE Plus, and PoE Plus Plus, is based on IEEE Active PoE, with proper detection, classification, and negotiation built-in. So, let's break down what those standards actually mean in real-world use. PoE L2.3 AF, 15 watts. This one's good for small, low-power devices. Think basic IP cameras, Wi-Fi access points, VoIP phones, doorbells, or even smart sensors around your home or office. PoE Plus L2.3 AT, 25 watts. Step up to PoE Plus for more demanding devices, like PTZ cameras that pan and zoom, advanced Wi-Fi access points, small network switchers, or even small LED lighting setups. PoE Plus Plus L2.3 BT, 60 to 100 watts. This is a heavy hitter, perfect for high-power devices, multi-megapixel PTZ cameras, large digital displays, all-in-one desktop systems, PoE powered laptops, or industrial devices like access control panels. And just to be crystal clear, all of these standards are only existing in Active PoE. PoE, PoE Plus, and PoE Plus Plus are IEEE standards. They rely on detection, classification, and power negotiation before anything energized. Passive PoE does not follow these rules. In the next video, we're going to talk about PoE ports and total power budgets, so you never run out of the power. Hit follow and turn on notifications. You don't want to miss it.